Welcome to the video lesson for Geometry 6.6, Use Proportionality Theorems. So as we transition into this virtual term, a couple tips for you as you go through these video lessons. I would highly recommend to read through the notes documents multiple times. The PDFs will all be in Google Classroom. Also, as you go through the video, you can pause, go back, replay any sections that you need to as you go through the notes. If you don't have your own printer at home, I would recommend doing your notes on any sort of lined paper or your own copies. If you have a printer at home, I will also have the blank copies in PDF form in Google Classroom for you to print the notes packets at the beginning of each chapter and complete the notes for the sections just like we did in the normal classroom setting. Otherwise, in the books, the lessons cover many of these same examples as my notes, just like before. Feel free to go in, look at the lessons, read in detail for sections that maybe you need a better understanding of. Make sure you use all your resources. There's plenty of online resources as well if you are confused on any topics. And please make sure to take advantage of the office hours and email me with any questions. So to begin with the notes for this lesson, as we go through, I'm going to pause at different points possibly or switch over my screens, so bear with me, and here we go. So starting this proportionality theorem section, we theorem 6.4, triangle proportionality theorem. That theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So you can see down here with the star section, if TU is parallel to QS, then RT over TQ is equal to RU over US. That is your proportionality statement. Over here on the right, you can see the contrapositive to that theorem going in reverse, where if sections are not proportional, then they are not parallel. The other main theorem to start is 6.5, the converse of triangle proportionality theorem, which states if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So looking at this example here, RT over TQ is proportional or equal to RU over US. Then line TU or side TU is parallel to side QS. And on the right, we have the contrapositive to theorem 6.5. If TU is not parallel to QS, then those segments are not proportional. So looking at example 1, in the diagram, we know side QS is parallel to UT. They know the distance of RS is 4, ST is 6, and UQ, that should say UQ, is 9. What is the length of RQ? So we'd set up our proportion, RQ over QU, looking at those two on the same side are proportional. And then we have the other side, RS over ST. So our proportion is x over 9 equals 4 over 6. Remember, for a proportion, you want to cross multiply, then divide. So 4 times 9 is 36. 6 times x is 6x. Divide both sides by 6, and we know segment RQ is 6. Example 2 is looking at a shoe rack. Picture here on the side. On the shoe rack shown, AB was 33 centimeters, BC 27, CD 44, and DE 25. Explain why the gray shelf is not parallel to the floor. So the gray shelf is basically segment BD here that they diagrammed on the side. So what we'd want to check are the proportions, looking at the sides. We have CD along this side and DE. So CD over DE. And then we have on the back side here CB over BA. which you can see set up here in purple. 44 over 25 is not the same as 9 over 11. They do not simplify the same, as you can see. So BD is not parallel to AE, explaining why the shelf is not parallel to the floor. In example 3, they ask you to find the length of YZ. So same idea with our proportion here. We want to set up WX over VW, and then YX over YZ, which we're trying to figure out. Cross multiply and divide, and it would be 315 over 11. Feel free to write that as a decimal or leave it as the fraction as you see here. In example 2, they ask us to determine if side PS is parallel to side QR. So in this case, we want to set up the proportions and see if the two sides are proportional. So we'd have the 90 over 50 going along the top, and then going across the bottom, the 72 over 40. Both situations simplify to 9/5, so those segments are parallel. Then the next two theorems we're looking at today are 6.6 and 6.7. 6.6 states if three parallel lines intersect two transversals, then they divide the transversals proportionally. So in this case, remember a transversal is referring to the line L in this example, or M. Those are the ones that cut through our three parallel lines of R, S, and T. So our setup there would be UW over YW, or WY, is proportional or equal to VX over XZ. Then in theorem 6.7, it states if a ray bisects an angle of the triangle, so in this case we're looking at ray CD, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So in that case, they're talking about segment AD and DB, which would be proportional to CA and CB. So example 4, applying one of those two theorems, they told us in the diagram at the right, angles 1, 2, and 3 are all congruent, and then they gave us the measures of GF, DE, and CD. They would like us to find the distance of HF, which would be between Main Street and South Main Street. So we're looking at this piece here of HF, Main Street down to South Main Street. So some pieces that we know to begin with, we know line FE, GD, and HC are all parallel because angles 1, 2, and 3, seen here, are corresponding angles, and if they are congruent, then we know the lines are parallel. So in that case, we can state HG over GF is equal to CD over DE, which also means HF, this whole side, over GF, this small segment, is equal to CE, this whole distance, over DE, that small segment. In that case then, HF over 120 equals 450 over 150, cross multiply and divide, and HF equals 360. Example 5 states in the diagram, angle QPR is congruent to angle RPS. Use the given side lengths to find the lengths of RS. So looking at this, we could state proportion RQ over RS equals PQ over PS. So we're looking RQ, this small piece right here, over RS, the bigger piece down here. and then PQ, the small piece up here, over PS, that longer side there of that bigger triangle. Now we have to go into a little bit of algebra. So once our proportion's set up for the cross multiply divide, 7 times x is just 7x. For the 15 minus x times 13, you have to make sure you use a distributive property. So 13 times 15 is 195 minus 13x. Then we'd add the 13x to each side. 20x equals 195. Divide each side by 20, and x equals 9.75. And then the last example for this lesson, example 6, asks us to find the length of AB in both of these examples. So in example 3 here, we have AB, the missing segment here, just made it into the variable of x. We know that has 16 along this side that corresponds with it, so I set it up as 16 over x equals, and then across bottom, 15 over 18. Cross multiply and divide, 18 times 16, divide by 15, and x equals 19.2. Then in example 4, looking at this triangle, we could set it up proportionally, but what you should notice is if this segment here from CD is 4 and DB is 4, we are cutting the right angle of A in half down here. So if CA is 4 square roots of 2, AB is also 4 square roots of 2. You could set up the proportion and find that same measurement as well. So you will see your practice problems to go with this lesson are on pages 400, 401, numbers 1 to 19 odds. And if you have any questions on the lesson, any of the practice problems, if it's office hours, see the expectations document on how to contact me there. Otherwise, please feel free to email.